Hello, everybody, and welcome to AI People. Today, we're talking to Alexandre Pasquiou, who is the CEO at Neuralk, which is a predictive AI platform for business data. Greetings, Alexander.
Nice meeting you, Ben.
So we always kick the podcast off by asking for some predictions on the AI industry as a whole. So which area of AI do you think is primed for a big breakthrough that perhaps people aren't focusing on at the moment?
I think today you hear a lot about Gen AI, but Gen AI is super good at generating content, at orchestrating simple workflows, or even as a user interface. But one of my deep belief is that they are missing where there is true value for companies. And this value, it lies in their core data. And this data has been stored for years in tables, which is a modality, a format in which LLMs especially have a very big difficulty to process and to understand. They don't understand schema logic. They don't understand relational. They don't have a relational understanding of multimodal data. And this is why Gen AI, not completely, but missed the most valuable part of enterprise AI. And the true revolution that will capture this enterprise AI value is what we call predictive AI. And this is what we address with tabular foundation models.
Okay, we'll get into that in much more detail as we go through the podcast. So next question, how do you expect the balance between foundational models and traditional ML to evolve over the coming years?
One of the reasons that we launched Neuralk is that the ecosystem of classic machine learning models to address tabular prediction has not evolved in years. Like we're talking more than 10 years. And at the same time, there were a lot of novelty going on in unstructured data, meaning text, vision, code, with transformer-based architecture. And so we built Neural to translate this technical revolution to tables. And this is why we've been working on this foundation model for tabular data based on transformer architecture. And we believe that there is a huge increase both in terms of performance and scalability to reach there. This is the beginning of the industrialization of data science, basically.
Yeah, okay. So before we jump into kind of talking about Neuralk in detail, could you just give us a quick intro into your background, interested in kind of what got you into kind of data science and the AI industry?
I did a PhD before creating Neuralk. I spent 4 years pre-training language model to better understand language comprehension in the human brain. So basically, when I'm talking to you, which brain region activate and to do what. And I also did the first work on video brain decoding. So basically, we had a human playing a video game in an MRI machine, and from the brain activity, we are reconstructing the video gameplay. And the one thing that I observed while pre-training language model was that whenever there were numbers, whenever there were a structure in the data, these tools were pretty bad. And this is why we created Neuralk, and this is why we wanted to translate this transformer-based architecture to tables.
And why is it that kind of generative AI struggles so much with kind of table data?
Language models are bad on structured data because what make them good on text make them really bad at understanding tables. So basically, they have a way of pre-processing text by tokenizing it and predicting the next token, which completely flatten and destroy a lot of information you could find in a table, because the meaning of a column and the relation it has to respectively to another column or to a group of other columns in a table has a lot of meaning when you're trying to make a prediction. For example, imagine you have some tables in which you have, let's say, the age, the year of expertise of some people, and from one line to another, you switch, for example, the two values, and it could be complicated to imagine, so it's a bit of a bad example, but A language model will have difficulty to understand the fact that you just flip the value and that the meaning has been reversed, while classic machine learning and tabular foundation model, they're not sensitive to this kind of transformation. And so they're able to understand this relationship between columns, between lines, between rows in your tables, and make prediction out of it. They truly understand what a distribution means, where and multimodality, because in a table you can get numbers, you can get categories, text, and so you need this understanding to predict fraud, to predict the category of a product, or even to predict the evolution of some stock in a given market.
So do you want to introduce Neuralk? And you've talked a bit about the kind of problem or the gap that you saw in the enterprise AI market. How is Neuralk specifically solving these problems?
So at Neuralk, we are building the predictive layer for enterprise. So basically, we are industrializing data science. Today, in every company that you meet, there is this compute layer, so the hardware on which everything runs. There is the data layer where everything is stored. But on top of that, whenever the company does data science, this is a kind of constellation of one-off projects, completely independent from one another. And for each project, you will get a team of more than 5 people during 1 to 6 months, and most of the time it never ships in production. And our ambition at Neuralk is to reduce that to just one engineer that will, thanks to our product, be able to put in production a predictive workflow with state-of-the-art prediction. Whatever is the use case, whatever is the industry, whether it is churn prediction, revenue prediction, stock market prediction, fraud detection, and so on. And yeah.
So where do kind of teams struggle most at the moment, do you think, when they're kind of building these predictive models?
It really depends on the teams or the people you're talking about. For example, in finance, which is the industry in which we focus first, these people are quite experienced. They know their data. They know how to extract it. They have a lot of each day they do a lot of modelization. But for them, each tiny accuracy percentage that you can gain can mean millions per day. And so we see a lot of traction there. They're quite interested in using our model because our model is more efficient, more powerful than classic approaches like XGBoost, random forest, linear regression, or others. And so they directly see the ROI that they can generate thanks to our approaches. Other less technical teams, let's say, for example, in telecommunication, retail, energy, they are less expert in these modelization use cases. Even if the performance of the model, the accuracy of the model is an issue, they also have they have many other pain points. For example, they spend a lot of time scoping the problem, trying to understand how should the problem be defined. How should I process my data? How should I extract some meaning, some information from it? So all the feature engineering. In our product is helping these data scientists along all the creation of the predictive workflows from the problem description to the prediction with our tabular foundation model.
And is this a solution for data scientists, or can business users use it as well?
So we're starting with this data scientist because they have a deep understanding of what we're building. It's easier to start smaller. And the idea is to simplify, improve the UX through time to be able to capture more and more users, whatever the level of technicity, the technical level.
And when you're talking to customers, have any of them tried to kind of pre-train models or their own models? How do they sort of realize the value between your pre-trained model and perhaps trying to do it themselves?
Yeah, that's a good question. Most of the time, I think it's a bit redundant with one of the other questions. Like companies, they have this compute layer, the data layer, and this data science project. They are just one-off project, like one trick pony. You just force fed them one data set for one use case, and whenever you want to use this very model for another prediction, or you just modify a bit your data set, your input, then you have to start all over again. You have to retrain one of the model, and so usually there is just one person that will maintain the model in time. And 6 months later, when the person doesn't have time or leave for another company or another project or whatever, the model just drift, and so the prediction will the accuracy of the prediction will decrease. The model will be quite bad. At some point, will be no better than guesswork, and you go back to your drawing board, starting all over again. And so what we're doing is that we are industrializing this data science layer. We are allowing any company to build robust, maintainable workflows with state-of-the-art prediction.
In terms of kind of classical ML pipelines, like do you think they're going to become obsolete, or is there, certain use cases where they're going to make more sense and certain use cases where the kind of tabular foundational model that you're building is going to make more sense?
So if you make a parallel with language model that just didn't pop up at GPT-5 in a few seconds, yeah, it took times. There was GPT, GPT-2, and then there was
Yep.
the ChatGPT moment with GPT 3.5, where everyone went crazy by interacting with the chat and so on. And I believe, if I had to make one prediction, that 2026 is the ChatGPT moment of tabular foundation models. And so basically, I believe that in 2026, this tabular foundation model that will be better than any other classic machine learning algorithm. And any company will have an interest in switching from this simple single model to one model that is unified and used for all use cases. Imagine you have just one endpoint for all your use cases, while in the past you would have like 100 endpoints, 100 model to maintain for your 100 use cases, which is crazy.
And when you're talking to customers who, aren't perhaps familiar with what you're doing and the concept of tabular foundational models, like what's the biggest pushback? What's the biggest misconception that they kind of give you?
Again, it depends on the customer. So basically, some of them want explainability, they don't want a black box, and so they're afraid that because it's based on deep learning, it will be a black box, but it's not. We offer a lot of documentation as well as tools to explain, to interpret the prediction that are made. The only problem that they don't have a fine-grained access to the model, to the weight of every layer of our transformer-based architecture. So it can be problematic for some people that want to to get the full control, but it's quite rare that we get this objection. Like in finance, for example, most people they're interested in performance. If you can bring them the performance that they want, then it's fine. For others, if you can get them good performance as well as explainability, then it's fine. So everyone has its own constraint, its own expectation, and usually we can easily meet them.
And when you started building the company, obviously you had, the kind of idea and the concept formed, but how difficult was it, making that work and getting real results for customers?
When you want to build a foundation model, you need a good research team, and so basically we leverage 2 years of research on both the development of the architecture as well as the pre-training data that is used to train the model. And so basically, whenever you want to start building this kind of company, you need time to test proof the architecture, test proof the model, um, and then you need to iterate on real data with real client. And this is what makes the difference between us and some labs. The fact that from day zero we were iterating with design partners, sorry, in order to adapt our solution to their needs. While if you look at the way LLM evolved through time, they started from a research project and then they ask themselves the question, how can we monetize it? But in the end, when you do that, there is always issue because the model is not designed for the application in production that people thought of afterwards. And you have this um, this they can be hacked, they can hallucinate. So there are a lot of issues that you need to compensate afterwards that are not present in our current stack.
And where you are today, how do you balance that line between wanting to kind of be on the cutting edge of research and kind of pushing the model as far as you can take it versus having something stable which works and having that kind of simplicity in the product?
That's a good question. We have our first version in production of the model that we've developed so far, which is pretty good and quite scalable. Um, Now this is something that is improving continuously. We have a research team that are continuously working on the model, trying to improve it, trying to make it more scalable, trying to reduce the latency. And we need to. How do you know you're good? You especially when there is an infinite universe of use cases possible. And so to know you're good, you need to benchmark your model against other approaches. And so we define internal benchmarks as well as we use public benchmark in order to get an idea of how good the model is. We also test it on some private data. And the outcome of this experimentation is what tell us if we're going in the right direction. Once we're convinced of that, then we can update the product or update the model in production and verify in the last mile that it meets the constraint of our clients.
And when you're thinking about kind of go to market and you're looking at a new customer, what signals are you looking at that tell you that they're kind of ready for moving away from AutoML to a more of a foundational model approach?
That's a good point. Usually what we do is we just do a test and we show them that we get better performances. And that's it. AutoML has not really ever. It's a great research tool and you can get great performance, but we get a lot of negative feedback about it because it's usually a huge black box and difficult to interpret, to explain. And so people can get nice results, but in the end they lack something. And this something you can find it with our tabular foundation model as well as better performances. So in the end the choice is quite clear.
And in terms of kind of building the company, like what kind of culture have you put in place from a research perspective, when you're trying to attract kind of top research talent?
So we have three points that we highlight all the time. We want people that are mission driven, that will push the limit of what they're exploring, push the limit both in terms of research, in terms of product usage. Want people that are high performing, that give their whole to the mission. And being in a startup, it can be quite difficult, quite demanding. Things evolve at a crazy pace, and so people need to stay on board. And finally, there is a team spirit because without that, it will be difficult to keep this pace.
And you mentioned previously, like this was kind of born out of like a previous PhD that you'd done. What kind of made you want to kind of build a company and go into kind of entrepreneurship rather than stay in research?
In fact, before doing a PhD, I already wanted to build my company, but I wanted to do it nicely, and so I wanted to get the credibility, the knowledge, and the right network to have all assets in my hands the day I want to do it. And this is why I did my PhD in AI and neuroscience, because these were two topics that were of interest to me. And at the end of the PhD, everything had aligned, and it was a perfect moment to translate this transformer-based revolution to an entrepreneurial project.
So what drew you to the entrepreneurial life? Obviously something you've been thinking about for some time.
What drove me before? Sorry, can you repeat the question?
So what drew you to wanting to be an entrepreneur?
I don't know. Maybe you have it in your blood, in your bone at some point, and you. I always. I'm. What motivates me is the challenge, whether it's technical, whatever. There's the challenge, and I want to build something. I want to get to bring um, state-of-the-art techniques to the real world, to real application. I guess this is this entire mix-up of everything that made me converge toward entrepreneurship.
In terms of the problem space, like intellectually, like which part of it gets you up in the morning at the moment? What do you find most exciting?
Um, Two things. I'll keep it simple. The tech that we're building on the team. The tech is just incredible. Even at the beginning, I was impressed by the result we could get. Like when you train a model on some synthetic data, and yet it better performs on your client's data than the model they train on this very specific data, which is pretty crazy. And the team, because it's a human experience before all.
Great stuff. Well, thank you for coming on today, Alexander. If people want to get in touch with you, what's the best place to reach you? Are you kind of X, LinkedIn? Where do you spend most of your time?
In the office, but I will say LinkedIn if you had to send me a message. Yeah.
Okay. Well, thank you for your time, and thank you to everybody watching, and stay tuned for the next episode of AI People coming soon.